let's find the infinite sum and the interval of convergence for this geometric series. First of all, it's a geometric series, so the infinite sum is just going to be a sub 1 over 1 minus r. That's going to be the sum, the infinite sum of that series. So to find, we have to first find r. We know what a sub 1 is. A sub 1 is just 3. There's a sub 1. And the common ratio can be found by dividing one term by the previous one. So 3 halves x divided by 3. Let's do the math. That's just x over 2. So the infinite sum, or the you might call it the rational function that results from this, is going to be 3 over 1 minus x over 2. Now the question is, what's the interval of convergence for this? The interval of convergence, remember that whenever in a geometric series, whenever the ratio is between -1 and 1, that's where the interval of convergence typically. But now we have a ratio that's in, the common ratio right here is in the form of x. It's a variable common ratio. So we have to figure out for what x values this will converge, this sum will converge. And so to do that, we just plug in our ratio and then solve it for x by multiplying everything by 2. So if x is between -2 and +2, not including those, the sum right here will converge to a specific number. Now the next question they're going to ask us is, find the error that results when comparing the rational functions for x equals 0.2. Compare, they're going to ask something like this, compare the first 3 terms, for example, to the infinite sum and find the error at x equals 2, and they'll also give you another one like at x equals 1.2. So for both of these it converges because they're both in between -2 and +2. The way you would do this is first compute s for this example right here, and if you punch that in to your s equation up there, remember a sub 1 is 3. So if you punch that in, you'll get 3.3 repeating. And then if you just plug in 0.2 for x in your sum just for the first 3 terms, so the other one would be 3 plus 3 halves times 0.2 plus 3/4 times 0.2 squared. I'm just adding the first 3 terms. Then you'll get 3.33, not repeating. So if you subtract those, you get the difference, or the error is 0.003 repeating, which is very, very small. It's a very small error if your x value is 0.2. But if you do it for this example, 1.2, your s value is going to equal 7.5, I think, is what we computed. Is that right, 7.5?
Yeah, 5.88.
And the other one, if you plug it into the other one, if you plug in 1.22 for the first 3 terms, you'll get 5.88, was it? And the difference there, or the error, the difference is going to be 1.62. It's a relatively big difference there. So your difference can be big. Notice how small the difference is when x was a small number, was 0.2, I should say. Notice how small the difference is. There wasn't very much error to only add the first 3 terms compared to all the infinite number of terms. Because remember, this number, that s is essentially, that's the limit. That's the limit. It's never going to get bigger than that. If you keep adding, it might seem counterintuitive, but if you keep adding numbers, they're positive numbers, but they're getting so small that they're doing very little to the sum, and that's limited by, that's capped by 3.3 repeating. That's what a geometric, that's what an interval of convergence tells you.